Good morning, everyone. We are absolutely thrilled to be here today to present our project, the Makeup Product Recommendation System. This is a solution built entirely from the ground up in C, leveraging the inherent power of arrays and most critically bitwise operators. Specifically, we looked at a common everyday consumer frustration and sought to tackle it with an elegant, highly efficient programming solution. The problem, as you can see on slide 2, is universal. Consumers struggle to identify suitable product shades. Makeup purchasing is often confusing, especially when shopping online or without professional guidance. Crucially, this isn't just about finding the right color. It's a high stakes decision because a poor shade match for your foundation or blush leads to a poor look, consequently resulting in a disappointing purchase. So then why is this simple task so persistently difficult? Currently, selection relies on three highly inefficient and subjective methods. The first one, expert advice is required. You have to rely entirely on a beautician or makeup artist. Yet that person may not always be available. Second, the trial and error is necessary. You physically test multiple products, swatching them on your arm or face, and this process is messy and time consuming. Therefore, the result is physical cost and emotional dissatisfaction. This trial and error approach is inherently expensive and extremely inefficient and ultimately leads to buyer's remorse, product waste, and intense frustration. So, our goal therefore was to eliminate this friction. We wanted to transform what is currently a subjective, human judgment based process into a reproducible, reliable, algorithmic decision support system. To achieve this objective, our solution, detailed on this slide, provides algorithmic support by leveraging computational concepts in C. The structured data storage. Initially, we use arrays to hold all our product data. If you look at our C code, you will see we define four parallel arrays: product names, categories, shades, and skin tones. This structure is critical because it allows us to link all product information together by its index. Next, we use basic if statements and user input initially filter products based on simple high level criteria like the user's specific skin tone. Now, the next one is the bitwise logic, and that is the true heart of our project. It provides a complex yet incredibly efficient and scalable method for matching multiple overlapping product categories like best for oily skin and best for warm undertones simultaneously. Before we dive deep into the bitwise magic, let's briefly look at the foundational C elements that hold the system together. The arrays, we use them for bulk storage and quick index based data access. Because we use parallel arrays, the product at index 0 in the product names array, liquid foundation is guaranteed to be linked to fair in the skin tones array at the exact same index 0. This parallel structure is how we keep the data synchronized. Now next we use functions such as display menu and find recommendations to create modular, reusable and easy to maintain code. This breaks down the program. For instance, the display menu function handles all the formatting and text for the user interface, separating the logic from the core computation. Now, the logic and input. We rely on standard C logic and input to ensure the system is dynamic, interactive, and responsive to the user. In our get user preferences function, we use the standard C scanf command to read the user's choice, and then we use a switch statement to reliably convert that numeric input like 1, 2, or 3 into the corresponding skin tone string like fair, medium, or dark needed for the filtering process. This foundation of arrays and functions allows the system to work reliably, but the real technique innovation lies in the filtering speed. We have to process hundreds of products and filter them across a dozen categories in milliseconds. Now, to explain exactly how we turn categories like lipstick and blush into fast binary decisions using bitwise operators, I'd like to now hand it over to Zainab.
Hello everyone, today I'll be explaining the core logic and the bitwise part of our recommendation system. To understand it carefully, first let's talk about the flag system. In the flag system, each product category is given a unique number, which is a power of 2. For example, the foundation is given number 1, lipstick number 2, blush number 4, and eyeshadow number 8. You can see that all these numbers are in the power of 2, and in the binary, they have a unique combination of zeros and ones. This means that each category has only one on bit, and that helps us check and matches very quickly. Instead of comparing long words like foundation or lipstick, the program only compares small numbers, which makes it much faster and more efficient. You can see a code here in which we have used the string comparison function. This part of the code belongs to our get category function. It checks which category the user picked and returns its numbered flag. For example, if the user selects blush, it returns 4. These numbers are then used in matching later. Now, to understand the logic part, when the user selects a category and skin tone, both are stored. The category is converted into its number flag. For example, lipstick becomes 2. Then the product goes through all the products one. Then the program goes through all the products one by one. It uses the bitwise AND operator to check if the category matches. If the result is not 0, that means both categories are the same. Then it also checks if the skin tone matches using a normal string comparison. As you can see in the code here, we have used a function of if and string comparison. It says if user flag and product flag not equals to 0. This line is the main logic of our system. The first part, which I've said it earlier, user flag and product flag not equals to 0, uses a bitwise AND operator to check the category match. The second part, the string comparison function of skin tone, checks if both skin tones are the same. If both are true, the product is recommended to the user. Now moving on to the next slide, in which we're talking about the system architecture. The system has three main parts: the input part, where the user selects their skin tone and product category; the processing part, where the bitwise logic runs and finds matching products; the output part, where we display and recommend the items. This structure keeps the code organized and easy to understand. In the code here, the get user preferences function and the find recommendation function, these two lines shows how the flow works. First, the function takes the user's input, and the second one finds and prints the recommendations. And in this way, the flow works. Moving on to the slide of layered logic, our code is written in layers. Each function has its own clear role. Sorry, it was the previous slide. Yeah, so here we can say that the code is written in layers. There are different functions here: the get user preferences function that takes the user input, the get category flag function which gives number flag for category, the find recommendation function which checks and matches using bitwise logic, and the display all product function that shows all the products if the user wants. This structure keeps everything neat, readable, and easy to fix and expand later. You know why this is necessary? Because separate layer also make it simple to add new features in the future, like more makeup or filters. Moving on to the next slide of the uh, built-in product list. Our program already has a built-in product list, which means all the product names, categories, and skin tones are saved directly inside the code. This makes testing easy, and we don't have to use an external file. In the code that you can see, the char product names, max products, here we have used arrays as well. We have stored all the product data in arrays, like I've told you before. For example, the liquid foundation or the matte lipstick are already written in the code. This program uses this list to to search and match the right products for the user. Now the next slide of program flow and do while loop. The whole program runs inside a do while loop. This is necessary to understand because this loop shows the main menu again and again until the user chooses to exit. It also allows user to check multiple categories or see all the products without restarting the program. Here I've mentioned the code as well. the do function and the while function loop actually. Here the menu repeats using a do while loop. The program keeps running until the user enters 3 to exit. It makes the system interactive and easy to use. So, to sum up my part, I would say that our system uses bitwise operators and a flag system to match products quickly. It's clean, layered, and efficient. It also runs smoothly through a loop and can easily handle bigger data in the future. This ends my part, and now I will hand it over to Aimen to continue.
Assalamu alaikum. Now I will explain the code demonstrations and its results. Let's see how all this technical work comes together. At the heart of our code are three key functions. Number one is get category flag. This takes the user's simple string input like lipstick and translate it instantly into its unique integer bitwise flag. Like for the lipstick, it's 2. Number 2, find recommendations. This is the main loop that iterates over every product in our array database. Number third one is the match logic. This is basically the critical line of our code. It uses a single conditional check combining the two logic type. It checks for the category match using the bitwise AND operator and checks for the skin tone match using a simple string comparison. This is how we efficiently find a match across all criteria. Now I will explain you the system results in action. The output is very clear and effective. We have the two scenarios like if the match is found or if the match is not found. When the user inputs a fair skin tone and requests a foundation, the system quickly returns all matching products from the dataset like liquid foundation and BB cream. If the system provides robust handling for non-matches, if a user inputs dark skin tone and foundation and no such product exists in our catalog, it correctly informs the user that no matching product is present here or no matching product is would be found. Now, it's the simple loop that we does. In future, what we will do, I will explain you. The current system is a robust functional foundation, but the potential for future version is very exciting. Our immediate next steps would include expanding the dataset, like we will add the hundreds more products for real commercial relevance, developing a GUI, graphical user interface, moving beyond the command line interface to a graphical user interface, integrating a real database, shifting from in memory arrays to a database like SQL for external dynamic data management, and the last one, deployment. Deploying the system as a web or mobile application so it will be used effectively by everyone. Now, I will conclude our project. In conclusion, this project successfully transforms the subjective and inefficient process of cosmetic selection into reproducible, computationally efficient system. Our key takeaways are we successfully use arrays for efficient data storage. We proved bitwise operators are an efficient and scalable method for complex multi-category filtering. We created a practical user-centered application in the C language. Thank you. That's ended our presentations. When we run the program, it will show the three categories. Number one, get makeup recommendations. Number two, view all products. And number three would be the exact one. If we choose the option number one, it will show the makeup recommendation like what we want. We will then select our the skin tone according to our face. First one, the fair, medium, dark, whatever you want to choose, you will select it. Then select the category of whatever makeup you want to do. Like you want to choose according to your skin, foundation, lipstick, blush, and eyeshadow. We will choose the number two, lipstick. So for the fair skin, the matte lipstick would be great on your face.
So we have see how the option number one of get makeup recommendation works. Now, if we choose option number two of viewing all products, you can see that the program actually shows the user all the products that it has stored, the all the categories of the foundation, lipstick, blush, eyeshadow, etc. In this way, the user can see all of the categories present if the user want to view it. And if we choose option number 3, the program ends and displays the goodbye message. And this way, the whole program runs and actually gives the user ideas of makeup recommendation according to their skin tones.